Hi, and welcome to another edition of Math with Mr. Douglas. Whew, it's getting hot in here. Today, we're taking a look at two-way tables. Yes, and in the challenge section, we're going to be looking at some different histograms and frequency charts. All right, let's get at it. Here we go. Did you notice that the audio was sounding a little bit better for the intros? Yes, I have upgraded some of my camera recording equipment to make it sound a little bit better. So hopefully it'll be a little bit more enjoyable when you're watching these videos. Today we're talking about two-way tables. So two-way tables are pretty cool. They let you be able to get a couple of different pieces of information and be able to interpret them. So what am I talking about here? Well, here's what a two-way table might look like. So we call these two-way tables because there's basically two things that we're looking at. Go figure, right? So that's the key here. What are we looking at here? We're looking at types of programs. We have dance, sports, and movies. And we're also looking at gender. So this is the first thing that we're looking at, like gender. And the second thing we're looking at is type of program. Okay, let's try and take a look at what happens here. Now there's some different things of the table that we need to basically be understanding. So a couple things is, just let me kind of change colors here. There are some key numbers in here. Now this right here is the total, so always in the bottom right hand corner, the total amount like of people asked. So typically we're talking about surveys. So for this one, 50 people were surveyed this. Okay, so we call, that's kind of the total. So that's what it's out of. So there's 50 people. But you see all these numbers, and if we're looking at all the numbers, they definitely add up to more than 50. Well, we have something called, and these ones here, I'll do an orange. So these ones here, we call those the marginal frequencies. So how often they happen? Now, how do you get them? Well, for the marginal frequencies, you add a cross. So you add a cross like that. So 16 plus 6 and 8 is 30. Great. 2 plus 10 and 8 is 20. Okay. And you also add down, because this is a two-way table, so we add down. So 16 plus 2 is 18. 6 plus 10 is going to be 16. And 8 and 8 is also 16. So the marginal frequencies are added across and down as well. Okay. That's pretty cool. And then what do you call, there's a lot of colors here, and what do you call all the stuff in the middle? All the stuff in the middle. So this stuff here, and that was a really bad circle. Here you go. This stuff in the middle. So not the marginal frequencies, all those sorts of things. And we call those things, we call them joint frequencies. Okay. So that's how you read a two-way table, and it gives you some pretty interesting things. So if we were going to go and start to say, oh, well, that's pretty neat. So what could you say? You could say that there are 16, let's just try and get some more stuff here. You could say that there were 16 girls who prefer to dance. Well, that's pretty awesome. And there were 8 men who prefer movies. Those are my kind of guys. And then you could also say, and now listen how I'm saying it, there were 16 people that preferred sports. You wouldn't know if it was guys or girls, but you know 16 in total. Now what teachers are going to go and do, and they're going to do some fun stuff to you, is they're going to go and they're going to make this table be a little bit more complicated. And how are they going to do that? Well, they're going to go and they're basically going to go and like erase this here. They're going to erase that here, and then they wouldn't have 30 here. Do you guys remember what that number was? What was that number? That number, or actually, let's keep 30 there. So they're going to go and they're going to go and blank out some things. So they're going to go and maybe blank this out. Maybe I'll blank this out like that. And they'll say, go and complete the two-way table. So how do you go when you figure stuff out? Well, you have to understand that you need to be able to go either this way and get to 30. So ask yourself, 16 plus 6 plus what equals 30? So you're probably going like, that's 22 plus something. Let's call the something x is 30. So x would have to be 8. Yay, I figured it out. That's awesome. So you know that 8 would go here. So you go, oh, that's 8. Okay, and your teacher's all happy. And you keep doing that, and you keep trying to figure out exactly what the different blanks are going to be. So that's what's going to happen. That's one thing that the teachers are going to have you guys go do. Then they're going to kick it up another notch, and they're going to go and say, well, you understand that. That's fantastic. But do you understand it when we want to talk about percentages? Whoa, percentages? Yeah. So here's a table that we're looking at boys and girls, and we're looking at languages that they're probably taking in maybe school. So you have Spanish, French, and German. Ironically, they don't have Chinese or Japanese, which I actually took in school. So how do you convert things to percentages? Well, it's not too bad. You have to look at the total. So we're going to take a look at the total, and we know that the total is 50. Right, it's right there. That's the total. 50 kids were asked. So if I want to convert this into percentages, I need to go and say, let's deal with the boys who like Spanish, who chose Spanish. It'd be 10 out of, 10, let's go and just change that. It's 10 out of 50. So 10 out of the total number of people that were asked, which was 50. And we know that as a percentage, right, if I want to make this a percentage, and percent is always out of what? It's always out of 100. We know that this number here, x, would end up being 20. So, which is 20%, which, as a decimal, which is what you're seeing over here, that's the decimal, is 0.2. Now, if you're like, how did you go and just do that instantly without showing me how the math actually worked? Go watch some of my older videos. There's a whole bunch of them. But basically, a little shortcut, 50 times what is 100? Times 2. Great, I'm going to times this by 2. That's how I got that to be 20, really, really quickly. And how did I get 20% to a decimal? Well, don't forget, to change things to a decimal, you just kind of go backwards 2 decimal places. And that's how I got 0.2. So that's how this ended up in here. Now, the same sort of thing works for reading your two-way tables. You read across and down, and you can see the total. Now, the total, a couple of things that always throw off some students is this, the 1.0. 1.0, they're like, well, there's one person asked. Well, no, 1.0 is 100%. And hopefully that makes sense. The total number of people that were asked for the survey has to be 100% of the people. Just pause, think about that a little bit, come back, and then go like, oh, that's right, Mr. Douglas. I totally get it. So that is when we're converting two-way tables into percentages. The same sort of thing will also work if a teacher goes and evilly, and yes, evilly is a word, they evilly go and start blanking out things. And they say, maybe they blank out this one right here. They go, what's that? So it's like a little puzzle you got to go and figure out. So you're doing the exact same thing that I just showed you before, but just dealing with with decimals or percentages. I like dealing with the decimals more so than percentages because it seems a little bit more cleaner than percents. The numbers are a little bit smaller. Just a couple things. Just don't do the common kid mistake and think that 5% is 0.5. Of course, it's not. It's not true. Sad face. Sad face crying. Because 5%, don't forget, is actually 0.05. What's with my writing today? 0.05. Okay, so don't make that little mistake. Okay, be careful. Besides that, that's two-way tables. Kind of fun. And there you go. On to challenge stuff. Okay, in the challenge section, we are going to be taking... Whoa! Where are we? Are we in a Star Wars battle scene? This is awesome. All right, but for the math, we are taking a look at frequency charts. Here we go. So we're going to be looking at histograms, and if you're thinking of histograms, and first off, was that a really cool Star Wars battle scene? Do you know which movie that was from? Good questions. All right, so when you're talking about cumulative frequency histograms, there is a difference. And I'm going to show you right now. So here's just a couple of, here's like a little bar chart. But then you have this one here, and I want you just to kind of think to yourself, what's different about this one? What's different? Well, couple things. Hopefully you guys are noticing. So this would be a cumulative histogram. And if you're thinking of root words, your English majors, you cumulate, right? Cumulate. That means add things together. So you can see these are stuck together. So they're kind of stuck together as opposed to your typical kind of bar graph. And also note that everything is always going up or at least staying flat because you're always adding things. So for a cumulative histogram, you're always going to see kind of an upward trajectory or a flat trajectory, and they're going to be stuck together. So we're going to be looking at cumulative frequency histograms today. So cumulative frequency, so how often, and a histogram, like a bar chart. Okay, so that's what we're going to be looking at to give you an idea of where we're going today. So here we go. Let's take a look at one. I'm just going to show you one right now and then talk our way through it. So here is one, and basically what we have here is a bunch of data. So here's the data that we have, and these are all scores. So over here, we're looking over here right now. How many, what's the frequency of people who scored 2? How many were there? Well, there's this one, that's 1, 2, there should be one more, 3. All right, so the cumulative frequency, CF, is 3. Well, that's pretty easy. Boom, there we go. Then how many people scored a 3? Well, there are 7 people. So what's a cumulative frequency? So basically what you're doing is taking this 3, you're adding the 7, and then you're getting the 10. So you're always adding down, and you can see you just kind of keep getting bigger and bigger. And that's how the cumulative frequency tables get created. So it keeps getting, is accumulating upwards. So how do I go and graph this stuff? How do I make an actual table? I'm glad you asked. Well, if you take a look at this, basically you're plotting your scores down here, and you're putting the frequency of them up here. So right here, you have how many people got 2? Well, 3 people got 2. So this bar here is 2, 3. The other bar there, though, like how many people? So this 3. Now you're looking at that and saying, well, there's 10. Does that mean 3 people got 10? Or how are we reading that? Like if these are the scores, so like, I'm sorry, does that mean 10 people got 3? No, that doesn't mean 10 people got 3 because we know 7 people got 3. What this represents is that there's a total of 10 people who at least got 3. So 2 and 3. Oh, interesting. So it's a cumulative frequency. This is adding things together. So that's how you read this one. So it's a little bit different. So obviously a tricky question that teachers might ask you is, like, does this mean that 3 people got 10 points? Absolutely not. It means that together there was at least 10 people who got 3 points because we know that it was 7 and 3. There we go. That's how you start to read them. That's how you start to create them. So that's a cumulative frequency. And basically another couple of things is that you're going to notice that things are always kind of going up. And there's different shapes of distributions that we should probably be able to talk about. So you're going to see different kinds of shapes. And that's way too big. You're going to see 4 different types of shapes, basically. You're going to see things that are, oh, that's a good one, that are skewed left. I'll show you ones that are skewed, you guessed it, right. We also have a symmetric distribution. You can probably actually guess what that looks like. And then also we have something called a uniform or flat. uniform, or flat. So what do those look like, those kinds of distributions? Well, something that is skewed left would basically like look something like maybe this, something like that. Something that would be skewed right would be something like this, like that. And then something that is symmetric, look at that. And then something that's like flat, there's really no change, uniform, you would say, it's like that. So you can see kind of like with a skewing left, it's kind of going like this, skewing right is kind of going like that, and symmetric is going like wee, and then flat is kind of going across. You call the very end of it, this is kind of fun, you call the very end of it here, you call it a tail. Cool. And there you go. Let's take a look at one and see if we can go and create one. That sounds like fun. So let's go and get rid of this, and let's get rid of that stuff. Oh, the magic of computers, instant erasing, which I like. And let's say we had this. Roller coasters. Who doesn't like a roller coaster? You know, the best roller coaster that I've ever been on. There's a wooden roller coaster in Vancouver at Playland. That's super fun. You basically go flying out of your seat. It's not safe at all. And you feel like you're really going to fly out of your seat. And I used to love going on that roller coaster as a kid. Wooden roller coasters, highly recommend. So here's a table showing people riding a roller coaster in different ages of what we have. So if we had to go and basically create that, now you have a couple of things. So remember, kind of like referencing, if you wanted to reference a little bit of how things look. So maybe I'll just go and just move this one over here. So when you're creating things, so if I'm going and creating the actual table, so just give you a kind of a reference. So here's the scores, right, the amount. And then these would be the frequencies, and this is the cumulative frequency altogether. So for us, if we're doing age and the actual frequency, so age would kind of like be the bottom part, so the score. So if I said like 10 to 19, and then 20 to 29, 30 to 39, you know, if I'm making this a really nice little table and trying to draw this as straight as I can, yes, that's about as straight as it's going to get. And, you know, so for 10 to 19, there's 16, there's 11, and there's 5. I'm just going to stop there just for... So for the cumulative frequency, though, I'd say there's 16, and then remember, I would go and I would add the 11. So 16 plus 11, and that would give me 27. And then I would go and add this, and that would give me 32, and so on and so forth. Okay, so that's how I would be going and creating that little bit of the table. And then if I had to go and actually create the actual table, so it's kind of giving the idea of how you would go and start to do this, because guess what? Teachers are going to ask you to do that. Here I would be putting down my ages, so I would have like 10 to 19. Then I would have 20 to 29, and then I would have my 30s. Oh, the 30s. I remember when I used to be in my 30s. That was exciting. Okay. And then you'd have, obviously, your numbers up here. Now, how you would start this, so look at the numbers here. So 16, 27, 32. Would you go up by ones? Would you? I wouldn't. I'd go up by tens. 10, 20, 30, 40, 50. That's kind of what I would do. So 10 to 19 would be kind of like 16. So there's my one bar. And then remember, 20 to 29 does not mean I do a bar of 11. No. It means I do a bar of 27. So it'd be a little bit bigger. And then I go up to 32. It's a little bit bigger, but do notice it is a little bit bigger because this is a cumulative one. So it's probably going to keep getting bigger. And you just kind of keep doing that. And that's how you would go and build your cumulative frequency histogram. Why would you want to do this? Well, it's another way to display data, and you'll also start to see some interesting things. If I said, let's take a look at, let's get rid of this, and let's get rid of this one here. Let's go back to this one. And let's say I started to ask you some stuff. I said, where's the biggest gain? The biggest gain between different things. So like I said that, you would look, I would say if you just look at this one, like where does the biggest jump happen in scores? Well, that's interesting. Why would I want to know where the biggest jump is in a data set? Well, that would make me ask a question. Remember, what does data do? Data hopefully makes you ask questions. So a lot of people sometimes are scared of data when they see like results. Results are awesome because they provide you questions. When I take a look at, say, student scores on math tests, it provides me questions. Why did so many students score fairly high in this test? Why did my students not score very high in this test? What was I perhaps doing wrong? What was the cause of that? Data provides you inspiration for questions. So for this, is like, so where's the biggest jump happening? Where's the smallest jump happening? So the biggest jump, all right, the biggest jump you can kind of argue. Is it this one? Like, is it this jump here? Is it this jump? Or is it this jump? They're pretty close. If I was looking at that, it's pretty close. I think it's this one, though. So how you'd go and do it is you'd say, oh, okay, so that's a horrible color to use. Let's try and use a different color. Let's try and use this color. You take a look at this. So what number is that there? That's 10. So that's the number 10. And then what's this number here? Well, this number here is 3. We know that. So the biggest range would be 10 minus 3. So that'd be 7. So the distribution there. And say, so where is that biggest jump happening? It's happening when people scored 3 points. So when people scored 3 points, that caused the 3 was the biggest jump. Kind of the biggest jump. Okay, so that might ask you, what happens for those kids who go between 2 and 3? And where's the smallest jump? Well, the smallest one would be between here, this one right here, this one, and this one. And obviously this one would be, I think, 25. And this one would be 23. So the biggest kind of smallest jump would be like 25 minus 23, which would be a 2-person jump. So the 2-person jump gains between level 7 there. So only 2 people gained there. So why was that the smallest gain? Why did only 2 people jump up that far? And that was very small. Maybe it's just the level of challenge of this, whatever this is. Who knows? But the idea is that data gives you inspiration for asking really good questions. Embrace data. Thank you for tuning in today with Math with Mr. Douglas. Remember, go and subscribe. Click the little button. We're almost at 100. It's really exciting. All right, have a great day. Till next time.